Hey folks, how's it going? This is Mr. Murray coming to you with a video, on changing forms of quadratics. I call this changing forms of quadratics 1 because there are a couple different kinds of layers to changing forms of quadratics. But what we're going to talk about today is this. How do I go from what we called factored or intercept form, and how do I take this and turn it into what I call, or I guess we call, standard form? And this video is going to be about how we do that, all right? So our goal is we want to make this up here look like this down here. And so what I'm going to do is I'm going to start by talking about it on like a conceptual level, what's going on. And then I'm going to teach you a strategy to really easily be able to do this in a visual way. All right, and then there's going to be some problems that I'll show you, one's for us to do together and one's for you to try on your own, and then I'll do afterwards. Okay, keep in mind there will be some point where we do learn how to do this, x minus h squared plus k, right? We will eventually learn how to do this in a subsequent video, that's vertex form. But I'm going to do this first, and what you'll see is that this will very easily extend to vertex form, because these are basically the same thing, except this is like x minus h. Instead of x minus p, x minus q, it's like x minus h because of the squared plus the k. And we'll totally see what that looks like coming up in probably a future video. Okay, so I'm going to start with the main idea. And as you saw today, hopefully in the do now, and if you haven't watched the do now, what I'm going to do is right now, I'm going to just have a link appear right up top. Okay, and I'm going to ask you to really make sure you've tried the do now, because the do now is a warm up to this idea of distribution. And what we talked about, and what you probably learned about coming into this year, is when you have a number multiplied by a sum or a difference like this, you take the number, you multiply it by each of the things in the parentheses, and you add the result. Now, this is a very similar idea when you have two things, right? Because here we have a scenario where we have the 2 that needs to be distributed, but we also have a unique scenario here because we also have an x that needs to be distributed. So how do we do both? Well, what we're going to learn is that essentially you first distribute the first thing. So first you distribute the x, and you get x times x, which is x squared, because anything times itself is that thing squared. And then you have x times 1, which is 1x, or just x, and that's completed the blue part. And then what you do is you distribute the red part. So I have 2 times x, which is 2x, and 2 times 1, which is 2. Okay, and then if there's any like terms, for example, this 1x and this 2x, we can combine them in the final answer. So we have x squared plus 3x's plus 2. And notice how we've gone from intercept form or factored form into standard form. And that's the idea behind distribution. And so what the majority of this video is focused on is a visual way to help you do that distribution a little bit more straightforward, and in a way that we can easily extend to other kinds of things that you might see next year. All right, so here's the process, and this process is what I call the box method, or sometimes we call it the area method or model. Okay, so what this is that this is just a way to do distribution visually. So the first thing we're going to do is we're going to draw a box. So let's pretend I've got x plus 2 times x minus 1 from the previous page. I'm going to draw a box, and you'll probably do a better job than me because it's a little bit easier when you don't have to draw on the stylus. So you're going to draw a box, and this box, well, what we want to do is we want to actually calculate its area. And we know the area is the length times the width. So what we're going to do now that we've drawn our box is we're going to put the terms of the first piece on top. And by piece, I mean x plus 2. and the terms of the other on the side. So I'm going to call this x plus 1. Okay, and what I've done is I've taken this box and I've broken it down into different pieces. So I've got 4 pieces here. So let's see if we can figure out each area. So this area, to figure out the area of this first box, I do x times x, which is x squared. To figure out the area of this box, I have a length of x and a width of 2. So the area is length times width, which is 2x. Here, I have a length of 1 and a width of x. So the area is 1 times x, which is x. And finally, here, I've got a length of 1 and a width of 2. So if the area is length times width, that would be 1 times 2, which is 2. So what I've done is I wanted to calculate the whole area of this, length times width, and what I've done is I've broken it down into 4 pieces. But the sum of those 4 pieces equals the whole. That is to say, if I add this x squared, this 2x, this x, and this 2 here, well, I'll get the whole area I was trying to find. Okay, so what we notice is, well, we have our x squared, and then very conveniently along this diagonal, we have a 2x and an x. So we add those for a total of 3x, and then we have our 2. And if you take a look back at the last page, well, what you'll see is that's exactly the same thing we've got. So what we're doing again is we're just doing distribution. So we found the areas of the small box, we added them up and combined like terms. These are the 4 small areas. This is the 3x combining like terms. And then if there were a number in front that was not 1, in this case it's 1. If this was like 2 or 3 or 5 or -6 or whatever, you would have to multiply in, but we do that at the very end. And so since a is 1, we're done here. And coming up, you will see some examples of me working with problems where a is not 1. So please take a second, and if this was something that was tough for you, go ahead, pause and rewind as much as you need, and then when you're ready in a few seconds, I'll move on to another example. Okay, so I'm going to keep the process here so we know our process, and we'll just keep working through it. So remember, the first thing we want to do is we want to draw our box. Okay, and remember, the standard form is the final answer. So up top, we're going to put x minus 10. On the side, we're going to put x plus 5, and now we're going to calculate the areas one at a time. So x times x, that gives me x squared. X times -10, that gives me -10x. X times 5, that gives me 5x. And 5 times -10, that gets me -50. Okay, so just think about how I'd multiply these all out. I think we're good with those. Now I need to combine like terms, right? So I've got my box, I've got my terms, I've got my areas, and now I need to add up and combine like terms. So these are the like terms, -10x and 5x. -10x plus 5x equals -5x. So you get x squared minus 5x minus 50. This would be your final answer because the a value is equal to 1. Now observe something here. Notice how when I look at these two numbers, and we'd want to think about how do these relate? Rather, how does this -10 and this 5 relate to this -5 and this -50? Well, what you might notice is that when you multiply them, you get the c value, -50, and when you add them, you get the b value. This is actually, these ideas and thinking through this are going to be really helpful because eventually we are going to want to go the other way. You could imagine if I wanted to graph something like this, how it might be easier to convert it into intercept form, get 10, 0, and -5, 0 really fast, and then graph it out from there. That might be easier than trying to plug into something like x squared minus 5x minus 50. So again, please make sure you understood what I did here. All right, rewind if needed, and then in a moment I will move on to another example. Okay, so here's a different example. Notice how here we had a negative and a positive. Here I've got a positive and a negative, so we'll evaluate what we see here. So I set up my box. I'll kind of try to go faster each time. So we've got x and 7, x, and make sure you do use the -9. The negative does matter. The fact that you're multiplying by a negative instead of a positive. So here you have x times x, which is x squared. Here you have 7 times x, which is 7x. Here you have -9 times x, which is -9x. And here you have -9 times 7, which is -63. So you're just multiplying length by width, one at a time. So we got our box, we got our terms in the top and the side, we have our 4 areas, and now we add them up. So I've got my x squared, and try to notice like some of the commonalities here. Hopefully you guys are starting to see some patterns and things that I'm doing over and over and over again that you're also probably going to be doing over and over again, right? Thinking about where are the like terms, etc. Okay, so I add those up. Is there an a? The a is equal to 1, so I'm done. And I leave this as my final answer. So again, please make sure you understood what I did here. Hopefully you're getting the idea. I'm going a little faster. And then when you're ready, go ahead and I'll move on to the next one. All right, now this one's a little bit more challenging. You can see that I have an a that is not 1 anymore. So we're just going to have to think about that. So you start off the same way. You build your box. Here's x minus 5 and x minus 10. So I've got x squared minus 5x minus 10x plus 50. So if I do that out, now look, there's an a. So I leave the a. I drop parentheses because before it was just 1. So 1 times something, it didn't affect it. But now it's 2 times this stuff. So I do want to make sure, okay, that I put the 2, because there is the 2 there, and then I open the parentheses. And in here, I'm going to put my answer to the box. So I've got my x squared. Now I've got 10 and -5. That's -15. And then I've got positive 50. And now I have to do a little bit of distribution. So I distribute the 2 to all 3 things. And if this is challenging, don't worry about it. We'll continue to work on it. And it's something we'll likely talk about if we have a hangout this week, assuming that's going to happen. Okay, and you can just see here that everything doubles. And now this is your final answer. So the big challenge here is that we threw in the multiplying by a. Because now a was not 1. So it was more than just leaving it once we finished adding up the stuff in the box. Okay, so again, please make sure you understand what we did here. And then when you're ready, go ahead and we'll move on to the next problem. Okay. So now we're on to the we do. And in the we do, I'm going to kind of try to be a little bit more prompting. And hopefully maybe you'll say out loud some of the stuff that I'm thinking. I don't want to be too developmentally inappropriate. I'm not going to make this like Dora the Explorer. But let's see what we get. So folks, our first step was to draw a box. Now what is going to go on top of this box? So you could put either one. I'm going to put x minus 8. And if I put x minus 8, what goes to the left of the box? What you're going to put is x minus 6. So let's go ahead and what do we do now? We do the interior. So x times x will be, it will be x squared. -8 times x will be -8x. X times -6 will be -6x. And -8 times -6 will be positive 48. So we have these all done. What are we going to do now? We're going to add up all the stuff in the box. So I've got x squared. And notice I've got my like terms. So these like terms combine to -14x, and then we have our plus 48. When you have positive numbers, it is optional to write the plus sign. And when you're out of the box in standard form, you definitely have to write the plus. But in the box, if you want to write the plus 48, that's your choice. I don't care either way. They're equivalent. If it helps you keep track of the positives and negatives, it might be a good idea. All right, is there any a value we need to multiply here? Technically, yes, there is an a of 1 that's hiding there. But remember, we're only going to multiply if it's not 1. And -1 is not 1. I just want to clarify. If it's exactly 1, then nothing changes, so we leave it. That's why I said if not 1. So hopefully this made sense to you. Please rewind if needed and pause if needed. And then in a moment, I will move on to the next example. All right, we're doing pretty well. We've got a couple more after this one. So notice again what's different here. So first, what am I going to do? I'm going to draw a box. Very good. Now be very careful when you draw this box. There are technically two ways you can do it. I want to be clear. In theory, you could distribute this first, and you could do -2x minus 6 times x plus 7. And if you were to box this, you would get the exact same answer. For now, let's hold off on that, and let's just stick to expanding out what's in here. So on the top, I put either x plus 3 or x plus 7. If I do x plus 3, what do I put on the left? X plus 7. Nice. And then here I'm going to write x squared. Here I'm going to write 3x. Here I'm going to write 7x. Here I'm going to write 21. Okay, so I bring this together. Remember, don't forget your -2. And we're going to do x squared plus 10x plus 21. Am I done? No, because I need to distribute the -2. So I distribute it, distribute it, distribute it. So -2 times 1x squared is -2x squared. -2 times 10x is -20x. -2 times 21 is not 41, -42. Now you are done. There's nothing more to distribute. You're all good, and you've got it. All right, so as we wrap up the I do's and the we do's, if there's anything you need to do to kind of recap anything, I encourage you to do that. I encourage you to check the description in the video for specific time links. But when you're ready, go ahead and we'll move on to our first you do problem. Okay, so here's a problem for you to try. So what I want you to do is this. We have this quadratic in intercept form or factored form. I want you to take this quadratic and using our method, convert it into standard form. So again, take a moment, pause the video, convert this to standard form. Then when you're ready, unpause and you can see what I got. Okay, so where we're going to start off with this one is, remember, we're going to start off by making our box. Okay, I'm going to make my this and this. What goes here is x minus 11 or x minus 13. You could do it either way. What goes here is whatever didn't go up here goes down here. So I've got x squared. This becomes -11x. This becomes -13x. And this becomes positive 143. You may need a calculator for that. So my final answer is x squared minus 24x plus 143. Again, as I just said, you are strongly encouraged to use a calculator. You can use Desmos.com. You can just go to Google.com and literally type -11 times -13 into the search bar, and it will tell you it's 143. Lots of different ways to do it, but it is important to be able to do those calculations out in some way. Right? So again, please make sure you understood this. Again, hopefully you're able to get it right and it was relatively straightforward. And then in a moment, we will move on to the last you try problem. All right, this one's just a little bit more spicy than the last one. So again, similar idea. We've got this quadratic 3 times x plus 6 times x minus 7. It's in factored form. So please take a moment, pause the video, use our method to convert to standard form, and then when you're ready, unpause, and you can see what I got. Okay, so last one here, we're going to set up our box real quick. So here goes our box. Okay, remember what's going to go on top of the box is x plus 6. On the left of the box is x minus 7. So I do this out, x squared 6x, negative 7x, and this is negative 42. So remember, because a is not 1, I put my a, I drop my parentheses, I get x squared minus x, because it's negative 7 plus 6, minus 42. Okay, because a is not 1, I do need to do this last step of distributing. So I get 3x squared minus 3x minus 4 times 3 is 12. 2 times 3 is 6. And that is it. There's no more to distribute. Okay, so please make sure, if need be, that you rewind and make sure you understand this. And then in a moment, I'll move on to some final words. All right, so folks, hopefully you found this video to be helpful. This is the general idea of this. So we have a quadratic in factored or intercept form, and it looks like a times x minus p times x minus q. But what we want to do is we want to convert it into standard form. And so to do that, our idea is that we're going to use the method of distributing. We're going to distribute out the x minus p to the x minus q, multiply by any a if needed, and it will turn it into this standard form. We started by talking about the idea behind distribution and how that works. And then we looked at some examples of how we use the so-called box or area method to break down the process of distribution so that it's a little bit more graphical, it's a little bit more user-friendly, and it allows you to put the pieces together in a little bit more organized way. So hopefully you found this video to be helpful. I am going to attach to today's lesson. If we're looking at the lesson online, I'm going to ask you to continue to work on some factoring problems, or rather some expanding problems. I'm going to ask you to check out my website I've set up for this so that we can make sure that we get some practice. You're going to want to go to expand.willnot.fail. And if you go to this link, expand.willnot.fail, it will take you to a little practice so you can practice doing this stuff out. And it will even check your work on the spot so you can see if you're right or wrong. And after a certain number of guesses, it is going to go ahead and tell you the answer so you can see where you're doing well and where you might need to work. So keep up the good work, folks. I'm looking forward to seeing everyone on Thursday. I'm hoping that we'll have a good turnout this week and we'll continue to work on this. Until next time, have a wonderful day. And remember, you can do it.